Hi, this is Dr. Abdul Rahim. Hope we are all doing well. So today we are going to discuss a new topic from linear algebra. So that is about the Gauss Jacobi method for solving the system of linear equations. So when do we use this Gauss Jacobi method for solving the system of equations is that when the system of equations is when the given system of equations are diagonally dominant. So what do you mean by this is, for example, if you see in this system of equations, that is 14x1 minus 3x2 is equals to 8 and x1 plus 5x2 is equals to 11. If you see the coefficients of x1 and x2 in the first equations, we have here 14 and here we have minus 3. So this is uh, the highest coefficient. Now, if you see in the second equation, the coefficient of x1 is 1 and the coefficient of x2 is 5. So now this is the highest coefficient. So now in this given system of equations, the diagonal coefficients are dominant in the given system. So such systems, to solve the equations of such systems, we use the Gauss Jacobi method, right? So now we will solve this one. So since the given system, since the given system is diagonally dominant, dominant, the given system is diagonally dominant. You see the diagonal elements, diagonal coefficients are dominant. So when the given system is diagonally dominant, we use the method called the Gauss Jacobi method or Jacobi iteration to solve the system of equations. So now, so let us consider this as equation number, this was 1 and this as. So now from 1, so let us find the value of x1. So from 1 what we get, so x1 is equals to, so from 1 x1 is equals to 1 by 14, 8 plus 3x2. So this is number 3. Okay, then from 2 we'll find x2. So x2 is equals to 1 by 5, 11 minus x1. This is 4. Okay. So what we have to do? So from the given system of equations, from the equation number 1, we will find the value of x1. So 14x1. So we will move these terms to the right hand side. It becomes 8 plus 3x2. So then the coefficient of x1 is 14. Divided by 14, we will get the value of x1. Similarly, we have to find x2 from the equation number 2. So what we have to do? We have to move this x1 to the other right hand side. So it becomes 11 minus x1. So coefficient of x2 is 5. So we will divide. Then we'll get the x2. Okay. So now since the given system of equations are diagonally dominant, so from the given system of equations, we have to find the variables x1 and x2. So now we will draw a table. So consisting of the items, variables, Then we have first iteration, then Then we have second iteration. Then we have third iteration. And finally, uh, fourth iteration. Let us see it. Okay. So now we have to, so from here, what are the variables? Let us write down the variables. X1. So x1 is equals to how much here? X1 is equals to 1 upon 14, 8 plus 3x2, right? Similarly, we have from 4, we have x2 is equals to how much? X2 is equals to 1 by 5 into 11 minus x1. So for the first iteration, what we have to do is we have to consider x1 and x2 as, we have to take x1 and x2 as equals to 0. So for the first iteration, what we have to do? We have to put in the equation number 3, we have to put x2 is equals to 0 and on in the right hand side, and in the equation number 4 we have to put x1 is equals to 0. So that is here put put uh, x1 is equals to 0 comma x2 is equals to 0 in the right hand side of equation 3 and equation 4. So therefore for the first iteration, the first iteration is represented by like this. So first iteration, so what we have to put? We have to put, so this is for the first iteration, what we have to put? We have to put x2 is equals to 0. So then it becomes 1 upon 14 into 8 plus 3 into x2, 3 into 0, 3 into 0, right? So 3 into 0 is 0. So therefore this is equals to 1 upon 14 into 8 plus 0 is 0. So therefore, so that is equals to, so that is 8 upon 14. So 8 upon 14 is how much? 0.571. This is 0.571. Similarly, for the second one, so second variable, the first iteration of the second variable x2, first iteration of x2 is equals to, what we have to put? We have to put here x1 is equals to 0. So we have to put x1 is equals to, so therefore that is equals to 1 by 5 into 11 minus 0. So this is equals to how much? 11 minus 0 is 11. 11 into 1 by 5 is 11 by 5. So that is equals to how much? 2 point, 2 point, right? So this is the first iteration. So what we have to do in the first iteration, in the equation number 3 and in equation number 4, in the right hand side, to get what we have to put, we have to put x2 is equals to 0 and x1 is equals to 0. So therefore, if I put, so the first iteration from here is equals to 1 by 14 into 8 plus 3 into 0. So 3 into 0 is 0, 8 plus 0 is 8. So that is 8 by 14, that is 0.571. Similarly, first iteration of x2. So put x1 is equals to 0. So therefore x2 first iteration is equals to 1 by 5 into 11 minus 0. So 11 minus 0 is 11. So 11 by 5 is equals to 2. So now coming for the second iteration. So the second iteration is denoted by, so this is the second iteration, right? Okay, let us know this one. Okay. So now second iteration of the first variable. So that is equals to second iteration. What we have to do? Same equation. So in this, we have to take this one 1 upon 14, 1 upon 14 into 8 plus 3x2, 8 plus 3 into x2. So here we have to take the value of the second variable for first iteration. So this value we have to take, that is 2.2. 3 into 2. So therefore, if I simplify this, what happens? 1.04. So we will get, simplifying, we will get 1.0. Similarly, for the second iteration of the second variable, so x2 second variable, we have to use the same equation only, but in place of x1 we will use this one. So that is equals to 1 by 5 into 11 minus x1. What is x1 from the first iteration? So x1 value is equals to 0.57. So this is 0.57. So therefore, on simplifying this, we'll get it as 2.085. 2.08. So here you see the first iteration of x1. So we got 0.571. Second iteration we got 1.04. Similarly, first iteration of x2 we got 2.2. Second iteration of x2 we got 2.085. Now let us go for the third iteration. So for the third iteration of the first variable, that is equal, same equation we have to use. So for the third iteration we have to use these values. So therefore 1 by 14 into 8 plus 3 into this x2, this value, 3 into 2.085. 2.08. So on simplifying, we will get the value as 1.018. 1.0, right? Next, for the second variable, third iteration for the second variable, so is equals to, use the same equation, but instead of this one, we will use, so that is equals to 1 by 5 into 11 minus, so instead of x1, we will use the value of the x1 from the second iteration. So x1 is 1.0. So on simplifying this one, we will get it, we'll get the value 1.99. 1.9. Now you see the value of x1 and x2 from the first iteration, 0.571, 1.04, 1.01. Similarly, for the second variable, first iteration value is 2.2, 2.08 and 1.99. So we'll go for the another iteration, that is the fourth iteration. So fourth iteration. So for the fourth iteration, we have to use this x1 and x2 values. So see the equation 1 by 14. by 14 into 8 plus 3x2. So we will use this value of x2 from the third iteration. So that is equals to 3 into 1.9. So on simplifying this, we will get the value as 1.01. So now for the second variable, fourth iteration. So is equals to, the equation is 1 by 5 into 11 minus, so x1 we will take this value 1.018. So now on simplifying this, we will get the value as 1.9, right? Now if you observe the values of the third x1 and x2 from the third iteration and the fourth iteration, we see that from the third iteration x1 value is 1.081 and here also we got 1.018. So x2 value 1.99, x2 value here is also 1.9. Okay, so now here as the values of x1 and x2 from the third iteration and fourth iteration are repeated. So here you see, here we have x1 value as 1.018, here also 1.018, and x2 value from the third iteration is 1.99, and here also we have x2 value from the fourth iteration as 1.9. So as the third iteration and fourth iteration values are repeated, so we stop, and the solution of the given system is, so the solution of the given system is, so x1 is equals to, so x1 is will be taken as 1, so rounded, and x2 will be taken as 2, so it is rounded. Okay, so this is the procedure for solving the system of equations for which the system is diagonally dominant. So thank you for watching my video. If you like my video, hit the like button and as well as subscribe to my channel. Thank you.